Combining a duplex outlet toggle switch and a three-way switch within the same three-gang electrical box with two feeds is permissible under specific conditions. It's crucial to ensure firstly that adequate space is available inside the box. Overcrowding can lead to compromised wiring and potential hazards. There must be sufficient room to accommodate all devices, wire connectors, and wire runs without causing undue stress or compression. Secondly, proper grounding is absolutely necessary. The electrical box must be effectively grounded to safeguard against electrical shocks. This grounding provides a safe path for fault currents, minimizing the risk of electrocution. Thirdly, adequate circuit protection must be in place. The electrical circuit must be protected by a circuit breaker or fuse with the appropriate amperage rating. This protection mechanism interrupts the circuit in the event of an overload or short circuit, preventing damage to equipment and reducing the risk of fire. Fourthly, compliance with local electrical codes is not optional. The installation must adhere to all local electrical codes and regulations. These codes vary by location and are designed to ensure safe electrical practices. Consulting with a qualified electrician is always recommended to ensure compliance. While combining these devices in a single box is legal if these conditions are met, there are reasons why you might want to consider placing the duplex outlet in a different location. One reason is convenience. Locating the duplex outlet in a more accessible area, such as a wall near a door or on a kitchen countertop, can enhance usability. Another reason is aesthetics. Separating the duplex outlet from the switches may create a more visually appealing arrangement. And a final reason is safety. If the duplex outlet is positioned close to the switches, there is a slight possibility of accidentally turning off power to the outlet while operating the switches. However, provided that the aforementioned conditions are satisfied, integrating a duplex outlet, a toggle switch, and a three-way switch in the same three-gang box with two feeds remains a legally compliant and acceptable practice. Now let's discuss the technical details of each of these requirements, starting with adequate space. The National Electrical Code, or NEC, provides guidelines for box fill calculations to ensure that electrical boxes are not overcrowded. These calculations take into account the number of conductors, devices, and fittings within the box. Each conductor entering the box contributes to the box fill volume. Devices, such as switches and receptacles, also have a volume allowance. The NEC specifies the maximum number of conductors and devices that can be safely installed in a box of a given size. Calculating box fill involves firstly determining the volume allowance for each conductor. This is based on the wire gauge. For example, a 14 American wire gauge, or AUG, conductor has a smaller volume allowance than a 12 AWG conductor. Secondly, determining the volume allowance for each device. Switches and receptacles are typically assigned a volume allowance equivalent to 2 conductors. Thirdly, calculating the total box fill volume by summing the volume allowances for all conductors and devices. The total box fill volume must not exceed the maximum allowable volume for the box size. Using the correct size box is essential for safety. Overcrowded boxes can lead to overheating, insulation damage, and potential fire hazards. Proper grounding is another critical aspect of electrical safety. Grounding provides a low impedance path for fault currents, allowing the circuit breaker to trip quickly and interrupt the flow of electricity in the event of a fault. A grounding system typically consists of a grounding electrode conductor, a grounding electrode, and equipment grounding conductors. The grounding electrode conductor connects the neutral point of the electrical system to the grounding electrode, which is typically a metal rod or plate buried in the earth. Equipment grounding conductors provide a path for fault currents from electrical equipment back to the source. These conductors are typically green or bare copper wires. Grounding electrical boxes involves connecting the metal box to the equipment grounding conductor. This can be accomplished by using grounding screws or grounding clips. Plastic boxes do not require grounding. Proper grounding ensures that metal enclosures are at the same potential as the earth, reducing the risk of electric shock. Circuit protection is essential for preventing overloads and short circuits. Circuit breakers and fuses are designed to interrupt the flow of electricity when the current exceeds a safe level. Circuit breakers are resettable devices that can be tripped manually or automatically. Fuses are one-time use devices that must be replaced after they blow. The amperage rating of the circuit breaker or fuse must be matched to the ampacity of the circuit conductors. Overcurrent protection devices, like circuit breakers, trip when the current exceeds the breaker's rating, such as 15 amps, 20 amps, etc. The National Electrical Code, or NEC, provides guidelines for selecting the appropriate size circuit breaker or fuse for a given circuit. Factors such as the type of load, the conductor size, and the ambient temperature must be considered. Using the correct size circuit breaker or fuse protects the wiring and equipment from damage due to overloads and short circuits. Local electrical codes and regulations vary by location and are designed to ensure safe electrical practices. These codes typically incorporate the National Electrical Code, or NEC, with local amendments and additions. Local codes may address specific requirements for wiring methods, grounding, bonding, and overcurrent protection. Compliance with local codes is mandatory and is enforced by local authorities. Permits and inspections may be required for electrical work. Consulting with a qualified electrician is essential to ensure compliance with all applicable codes and regulations. Now let's delve deeper into the National Electrical Code, or NEC, and its relevant articles for this specific scenario. Article 314 of the National Electrical Code, or NEC, covers outlet, device, pole and junction boxes, conduit bodies, fittings, and handhole enclosures. This article provides detailed requirements for the installation and use of these enclosures. Some key aspects of Article 314 include, firstly, box fill calculations as previously discussed, ensuring that the box is not overcrowded. Secondly, conductor bending space, which specifies the minimum bending radius for conductors inside the box. Thirdly, securing and supporting boxes, which outlines the requirements for securely mounting the box to a structural member. Fourthly, enclosure types, which defines the different types of boxes and their applications. Another relevant article is Article 404 of the National Electrical Code, or NEC, which covers switches. This article provides requirements for the installation and use of switches. Some key aspects of Article 404 include, firstly, switch ratings, which specifies the voltage and current ratings for switches. Secondly, switch connections, which outlines the proper methods for connecting conductors to switches. Thirdly, grounding of switches, which requires the grounding of metal switch plates. Fourthly, location of switches, which specifies the requirements for the location of switches in specific areas, such as bathrooms and kitchens. And finally, Article 406 of the National Electrical Code, or NEC, covers receptacles, cord connectors, and attachment plugs or cord sets. This article provides requirements for the installation and use of receptacles. Key aspects of Article 406 include, firstly, receptacle ratings, which specifies the voltage and current ratings for receptacles. Secondly, receptacle grounding, which requires the grounding of receptacles. Thirdly, receptacle types, which defines the different types of receptacles and their applications, such as ground fault circuit interrupter, or GFCI, receptacles. Fourthly, receptacle locations, which specifies the requirements for the location of receptacles in specific areas, such as bathrooms and kitchens. When installing a duplex outlet, the toggle switch, and a three-way switch in the same 3-gang box, it's important to consider the wiring configuration. The two feeds mentioned could refer to two separate circuits or a multi-wire branch circuit. If the two feeds are from separate circuits, each circuit must have its own neutral conductor. Sharing a neutral conductor between two circuits is generally prohibited, unless it's a multi-wire branch circuit. A multi-wire branch circuit consists of two ungrounded conductors that have 240 volts between them, a grounded neutral conductor, and originate from the same panel. The voltage from either ungrounded conductor to neutral is 120 volts. This configuration requires a two-pole circuit breaker to protect both ungrounded conductors. When working with electrical wiring, safety should always be the top priority. Firstly, always turn off the power to the circuit before working on any electrical components. Secondly, use appropriate personal protective equipment such as safety glasses and insulated gloves. Thirdly, double-check all connections to ensure that they're tight and secure. Fourthly, never work on live electrical circuits unless you are properly trained and equipped. And finally, if you are unsure about any aspect of the electrical work, consult with a qualified electrician. Let's consider some potential scenarios and how the National Electrical Code, or NEC, addresses them. Firstly, what if the box is located in a damp or wet location? In this case, the box must be rated for wet locations and all wiring connections must be protected from moisture. Article 314.15 of the National Electrical Code, or NEC, addresses boxes in wet locations. Secondly, what if the wiring is concealed in a wall or ceiling? In this case, the wiring must be installed in accordance with the National Electrical Code, or NEC, requirements for concealed wiring. Article 300 of the National Electrical Code, or NEC, covers wiring methods and materials for general wiring. Thirdly, what if the box is located in a hazardous location? In this case, the box and wiring must be rated for the specific hazardous location. Articles 500 through 516 of the National Electrical Code, or NEC, address hazardous locations. Fourthly, what if the wiring is exposed? In this case, the wiring must be protected from physical damage. Article 320 of the National Electrical Code, or NEC, covers open wiring on insulators. In addition to the National Electrical Code, or NEC, local codes may have additional requirements. It's essential to check with the local authorities to ensure compliance with all applicable codes and regulations. Factors influencing the decision to separate the duplex outlet from the switches include convenience. Placing the outlet in a more accessible location can make it easier to plug in appliances and devices. Aesthetics can be a factor as well. Separating the outlet from the switches can create a cleaner and more visually appealing appearance. Safety is also a consideration. Positioning the outlet away from the switches can reduce the risk of accidentally turning off power to the outlet. In summary, combining a duplex outlet, a toggle switch, and a three-way switch in the same three-gang box with two feeds is permissible if certain conditions are met. These conditions include adequate space, proper grounding, circuit protection, and compliance with local codes. While separating the outlet from the switches may offer some advantages, it is not required by code. When working with electrical wiring, safety should always be the top priority. Always turn off the power, use appropriate personal protective equipment, and double-check all connections. Consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can ensure that your electrical wiring is safe and compliant with all applicable codes and regulations. Now, let's explore the nuances of three-way switch wiring. A three-way switch is used to control a light or other electrical device from two different locations. The wiring for a three-way switch is more complex than the wiring for a single-pole switch. A three-way switch has three terminals. Firstly, a common terminal, which is typically identified by a darker color screw. Secondly, two traveler terminals, which are typically identified by lighter colored screws. The traveler terminals are connected to the traveler wires which run between the two three-way switches. The common terminal of one three-way switch is connected to the power source, while the common terminal of the other three-way switch is connected to the light or other electrical device. When wiring a three-way switch, it's important to firstly identify the common and traveler terminals. Secondly, connect the traveler wires between the two three-way switches. Thirdly, connect the power source to the common terminal of one three-way switch. Fourthly, connect the light or other electrical device to the common terminal of the other three-way switch. Fifthly, ensure that all connections are tight and secure. Incorrect wiring of a three-way switch can result in the light not working properly or creating a safety hazard. If you are unsure about how to wire a three-way switch, consult with a qualified electrician. When installing multiple devices in a single box, it's important to consider the dirting of conductors. Dirting is the reduction of the ampacity of a conductor due to the presence of multiple conductors in a confined space. The National Electrical Code, or NEC, provides guidelines for derating conductors. The derating factor depends on the number of current-carrying conductors in the box. For example, if there are 4 to 6 current-carrying conductors in the box, the ampacity of the conductors must be derated to 80% of their original ampacity. If there are 7 to 9 current-carrying conductors in the box, the ampacity of the conductors must be derated to 70% of their original ampacity. Derating is necessary to prevent overheating of the conductors. Overheating can damage the insulation of the conductors and create a fire hazard. When calculating the number of current-carrying conductors in a box, you must include all ungrounded and grounded conductors that carry current under normal operating conditions. Grounding conductors are not considered current-carrying conductors. Neutral conductors are only considered current-carrying conductors if they carry significant current. In a 3-wire circuit, the neutral conductor is considered a current-carrying conductor. It is important to consult the National Electrical Code, or NEC, for specific derating requirements. In addition to the National Electrical Code, or NEC, there may be local requirements for derating conductors. It's essential to check with the local authorities to ensure compliance with all applicable codes and regulations. When installing electrical devices, it's also important to consider the type of wiring method used. The most common wiring methods are firstly, non-metallic sheath cable, or ROMEX. Secondly, metallic conduit, such as electrical metallic tubing, or AIMT, or rigid metal conduit, or RMC. Thirdly, flexible metal conduit, or FMC. Non-metallic sheath cable is typically used for residential wiring. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. Metallic conduit provides a higher level of protection for the conductors. It is typically used in commercial and industrial applications. Flexible metal conduit is used for short runs where flexibility is needed. The choice of wiring method depends on factors such as the application, the environment, and the local codes. Each wiring method has its own advantages and disadvantages. Non-metallic sheath cable is relatively inexpensive and easy to install. Metallic conduit provides excellent protection against physical damage. Flexible metal conduit is easy to bend and install in tight spaces. It's important to select the appropriate wiring method for the specific application. When installing wiring in a box, it's important to use the correct type of connectors. Connectors are used to secure the wiring to the box and to protect the conductors from damage. There are different types of connectors for different types of wiring methods. For non-metallic sheath cable, cable clamps are used to secure the cable to the box. For metallic conduit, conduit fittings are used to secure the conduit to the box. For flexible metal conduit connectors are used to secure the conduit to the box. It's important to use the correct type of connector for the specific wiring method. Using the wrong type of connector can damage the wiring or create a safety hazard. When installing connectors, it's important to tighten them properly. Loose connectors can cause the wiring to become loose, which can create a fire hazard. Over-tightening connectors can damage the wiring or the box. It's important to follow the manufacturer's instructions for tightening connectors. Proper installation of electrical wiring and devices is essential for safety. Following the National Electrical Code, or NEC, and local codes can help to ensure that electrical systems are installed correctly and safely. Consulting with a qualified electrician can provide additional guidance and expertise. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock. Always turn off the power before working on electrical circuits, and use appropriate personal protective equipment.